Solving equations using factoring level 1A. Objective. I can solve quadratic equations by factoring. Remember when we have the shortcut and everything else, so make sure we know which ones we want to do. A quadratic equation in X is an equation that can be written in the general form ax squared plus bx plus c equals 0. Now, a, b, and c have to be real numbers, and a cannot equal 0. If a equals 0, then you do not have a quadratic equation. Now look at example A. Example A, 2x squared minus 13 equals x. But up here I said it has to equal 0, so we have to get this equation equal to 0. How are we going to get that equation equal to 0? We're going to subtract x from both sides because we want to move that x to the other side. You look for any like terms. Do I have any like terms on my left side? No, so we put them in order. 2x squared minus x minus 13 equals 0. Now it's in standard form and it equals 0. If we look at example B, problem, it does not equal 0 and we need it to equal 0. How do I move the negative 1? Well, I'm going to add 1 to both sides. And since we have a positive 7, which is a like term, I put the 1 underneath that. So I have 3x squared plus 4x plus 8 equals 0. So now my equation equals 0. The first method we use to solve by factoring is called the zero product property. We're going to use this to solve every type of factoring that we have. So what the zero product property tells us is if a times b equals 0, then by definition, either a equals 0 or b equals 0. It's the only way you can get 0. So what you're going to do is we're going to have our factors ax minus c and bx minus d, or plus, doesn't matter, equals 0. So you'll take both of whatever's in your parentheses in your first one, set it equal to 0. And whatever's in your second parentheses, set that also equal to 0. Now we just solve for x. So add c. So you have ax equals c, and then divide by a. X would equal c over a. Again, this would be a number, not necessarily variables. Then we do the same thing for the second one. Add d. Bx would equal d, then divide by b. X would equal d divided by b. So the first ones we're going to do today are when they're already factored, so we don't have to worry about that. So they're already in this property, ax and bx, and they all make sure they equal 0. Equals 0, equals 0, equals 0, equals 0. So we're good to go. So we're going to take our first parenthesis, k plus 1, set it equal to 0. Let's take our second parenthesis, k minus 5, also set that equal to 0. First equation, need to get the variable by itself. The variable is k, so subtract 1 from both sides. 1's cancel, so k equals negative 1. Second equation, want to get k by itself, so you need to add 5 to both sides. So you get k equals 5. Now, we do not write our solutions as coordinates. We would just write k equals negative 1, comma 5, or you could write negative 1 and 5. Let's do one more together to make sure you understand. Let's look at letter C. First parenthesis, 4k plus 5 equals 0. Second parenthesis, k plus 1 equals 0. Now, 4k plus 5, same thing as letter A, the first step. Need to get the k by itself, so we need to subtract 5 from both sides. 5's cancel, so I have 4k equals negative 5. Now, but the k is not by itself. How do I get the k by itself? Divide by 4 on both sides. So k equals negative 5/4, or you could have negative 1.25. Second equation, get k by itself, subtract 1 from both sides. So k equals negative 1. So you would write your solutions as k equals negative 1.25, comma negative 1, or negative 1.25 and negative 1. I'd like you to try examples B and D right now, and then once you have them finished, check back.